Everybody, welcome back into another fun and exciting Algebra 1 class. Today we are going to be talking about a different kind of an equation, and this type of equation is called a literal equation. The literal equation is called literal not because they're literally an equation, not that kind of literal. It's called literal because it's a letter equation, literal letter. Okay, it's not exactly the same, but the idea is there. Literal and letter. Okay, now here's what that means. You won't get an answer for these like x equals 2. You'll get an answer for these like x equals yz. Okay, they're just letters. They're all letters. And you might think, well, I don't understand because I can't solve it if it's all letters. Well, here's the thing. You can solve certain parts of it, and then you can solve what they're asking you for. We are on page number 70 in your book, if you want to turn there. And there's a couple of words there that I want you to learn. The first word is called dependent. The dependent variable. Now, the dependent variable, when something is dependent, it depends on something else. So, for example, when I was a child, I lived in my mom and dad's house, and I was dependent on them. My dad had to go to work, my mom had to go to work, they had to make money, they had to put food on the table. I couldn't do it myself. Now, when I was really, really little, I couldn't do anything for myself. I couldn't even feed myself, tie my own shoes. I couldn't do anything. They had to clothe me. I had to do everything. As I got a little bit older, I was able to figure out how to tie my shoes. I was able to figure out how to make a sandwich. I was able to figure out how to dress myself, all these different things. And as you keep getting older and older, you get a little bit more and more independent, less dependent. I'm not depending on somebody else. Well, now that I'm the dad, now I am independent. Not really, but I'm independent. In other words, I'm the one that goes out and gets the job. I can fix my own food. I can buy my own food. I can buy my own clothes. And now my children are the dependents. Now they're trusting in me to be able to do that for them. So that's kind of the idea of dependent and independent. And it works here in math too. The dependent variable depends on something else to happen. So the next one there is the independent variable. And the independent variable is not it's not dependent, or it doesn't rely on anything else. It kind of does its own thing. Let me kind of show you this. There is an example in your book where it says m equals 60h. M equals 60h. And here's what that says. The minutes are the m, so m equals minutes, and h equals, actually it's a small h equals hours. All right, now here's the idea. Here's what's going on here. If I have 1 hour times 60, that tells me how many minutes. So which one do you think is the dependent variable, and which one do you think is the independent? Okay, good. In this one, m is going to be dependent. Why? Because it depends on the h. Because if the h is 1, then it's 60. If the h is 2, it's 120. If the h is 3, and so on and so on. Okay, now, sometimes here's what happens in literal equations. And I know I'm not doing the greatest job of explaining this because we're going to keep going as this book progresses on, and as Algebra 2 progresses on, and as pre-calculus continues on, here's what's going to happen. We're going to keep expanding this topic and expanding this topic and expanding this topic. And it gets to be very, very, I'd say complicated is the right word. But it starts out pretty complicated too, because it's just all letters. Now there is a number here, but we can't figure this out. We need to know what h equals in order to figure this out. Somebody has to say, hey, h equals 4. Okay, now I can figure it out. Okay, and so that's what we'll be doing a little later on. But for right now, here's what we're doing. All that we're doing in these ones is I want you to be able to I want you to be able to kind of switch it around, what we call manipulate it, and come up with h. So they're going to say solve for h. How would we solve for h? Here's what you do. You get h by itself. You get h by itself. This is the trick, okay? How do we get h by itself? Well, I have to eliminate the 60 from this side. How do I do that? Well, if I divide by 60, it's going to cancel, and I'm going to get h all by itself. Now, don't forget, if I do it to one side, I have to do it to the other side. Now, here's where you're not going to really get an answer. You can't divide m by 60. You don't know what it is. There's no way to write an answer. It's not 2. It's not 5. It's just m over 60. And so this would be our answer. That's it. We can't solve it because there's nothing to solve. You can't divide 60. You can't divide m by 60. It doesn't work. Okay? So the answer to this one, solving for h, would be m over 60 equals h. Or you could write h equals m over 60. It's the same thing. Doesn't matter which way that you write that. Okay. Let's do another one. Let's do, here's a formula that you may be familiar with. Perimeter equals 2L plus 2W. Now, we had that one in 8th grade, 7th grade, probably 6th, 5th grade. Okay, you've been dealing with perimeter for a long time. But now, check this out. They want you to solve for the L. In other words, they're not going to tell you what the L is. They're not even going to tell you what the W is. They just want you to solve for L. Okay? So here's what we do. We want the L on this side, and we want everything else over here. So we're going to move everything else over to the other side. So we want the L on the one side. So this is the way that we would do it. We would solve it the same way as we solve any equation. Solve it with the plus and minus first. Okay, the addition principle first. So let's move this 2W to the other side. Minus 2W. Again, we're trying to get L by itself. We're isolating the L. So if we do it to one side, that's going to cancel. We have to do it to the other side. Well, there's no way to do that over there. So what does that look like? Well, it looks like P minus 2W. That's what it looks like. Equals 2L. Because we can't subtract that. There's nothing to subtract over there because P doesn't have a value. None of this has values. It's all literal. It's all letters. Now, we want to get the L by itself, so we're going to divide that by 2. We're going to divide this by 2. Again, we can't do anything here. Some of you are thinking, well, I can do that. No, you can't. Don't do that. Don't try to do that. That's a mistake. The reason is because this is what's called a binomial, and we cannot cancel in a binomial. We would have to do what's called factoring that out, and that's going to come later. So don't worry about that right now because you can't even factor in this one. You can't get that to come out. You cannot cancel that. That doesn't work, so don't try it, okay? So this is our answer. L equals P minus 2W over 2. And that would be the answer for that question. Okay, really, to be honest with you, that's all there is with these. You just solve for the letter that you want to solve for, and you follow the steps of the equation. Let's do one more, and we'll kind of get an idea of this. I am in your book on page number 71. Let's do AX plus 2A equals 3A. And they want us to solve for X. Solve for X. Interesting. Ooh, this looks like it might be hard. Well, let's try it and see what happens, okay? So here's what we're going to do. Let's get the X by itself, best we can. Well, what I would do is I would start off with this minus 2A from both sides. Okay, because that's going to cancel. And this is going to give us 1A or just A. So AX equals 1A or just A. You don't have to write the 1. And now I'm going to divide both sides by A. And now this one's interesting. Watch what happens here. This is crazy. This actually gives us an answer, believe it or not. This cancels, and remember it cancels to 1. When things cancel, they cancel to 1 in algebra. Because whenever you divide anything by 1, you get, or divide anything by itself, you get 1. So 7 divided by 7 equals 1. Well, A divided by A gives you 1. So watch what happens here. When I divide this out, I get 1x or just x equals, well, what happens here? Well, I just said when we cancel, we get 1 over 1, which equals 1. So in this one, we actually do get an answer. It gives us 1 because all of the a's canceled. And when all the a's canceled, we get 1. Be careful that you don't write 0 there, because a lot of students will want to say, oh, everything canceled, so I got 0. But in algebra, when I'm saying canceling, that means that it cancels to a 1. Okay, it cancels to a 1. Because when we divide anything by itself, it always equals 1. All right, so there's kind of a little trick there. Every once in a while, it'll give you an answer. Every once in a while, you can find that the answer actually is 1. Okay, let's do one more, because these are so much fun, I know, and you love them. W equals 4 times P minus Q. And we want to solve for Q. All right, so what does this look like? Well, they're getting more and more complicated, right? Well, sometimes what we have to do is we actually have to do what we can do. Remember that step. In this case, we are going to go ahead and distribute this. This is going to make it easier for us to solve. 4p minus 4q. All right, now, again, I want q. So I'm isolating this guy right here. So I want to subtract 4p from both sides. That's going to cancel that 4p, and I'm going to get w minus 4p equals negative 4q. Now I'm going to divide both sides by negative 4, and that's going to cancel, and that is going to be my answer. Q equals w minus 4p over negative 4. Now we'll learn something a little bit later in algebra. I'm not going to try to teach it to you right here. Typically, you would not want your denominator to be negative. So what you would do is you would multiply, you would basically try to get the denominator to be positive. So another way of saying this would be negative w plus 4p over negative 4, or over 4, sorry. I'm multiplying negative 1 times both of these. Okay, so you saw me distribute right there. That gave me that. And then times that gives me positive. It's the same thing. And again, that's pretty complicated. If you can get that right now, that's awesome. But it's something that we're going to continue to work on all year is making sure our denominators are always positive. You never want your denominator in math. You never, I say never, but in algebra, you never want your denominator to be a negative unless they ask for it in a negative. But typically, you're going to want your denominator to be positive. I would not mark you wrong if you gave me this answer. So you give me this answer, fine. Not a problem right now. You change it to this, I love it. That's awesome. Okay? That means you're really getting it. But if you're not getting it quite yet, you don't have to change that yet. We'll have lots of time to figure that out this year. Okay? And so every time we get one of those, I'll kind of talk about it a little bit more. All right, well, that's all I have for you there. There was a lot there. Make sure that you go back and rewatch some of that if you think you might have missed anything. Lots of stuff going on there. But keep practicing these literal equations. They're a little bit tougher because you're not getting answers, but you're going to follow the same exact steps that you would in a regular equation. Okay? All right, we'll see you later. Bye-bye.